Hey, Math One, we're going to do some quick notes on section or task 1.4, starting on page 28 in this box where it says function notation. So function notation gives you the input and the output of a function. And we would say this as f of x equals y, where x is going to be our input. So that's our input is the x. And y will be our output. It's what we get out of the function. So if we have those function machines that we saw before, we are putting in an x value and getting out a y value. So the inputs are all the x values and the outputs are all of the y values of that function. Okay, so sometimes we don't have a machine, we don't have a list of steps. What we have is an equation, and we're only given the input of a function. And it's our job to find the output. And that's called evaluating functions. So evaluating functions can look different depending on the representation you're given. So for instance, in this first problem, we have a table of values, and we are given the name of the function, which is d, and we're given the input of the function, which is a 2. That is our input. So we have to identify where the inputs are in a table, and those are going to be these numbers right here. The minute number are the inputs. So above that, I'm going to write input, and those are also our x values. On the right-hand column, those are our outputs, which are our y values, and those are going to be these numbers right here. So that's how we can tell which one's which. So the question is, if my input is 2, what is the output that is associated with that? So I'm going to go down and I'm going to look at the table. I'm going to find that 2 of an input and see what the output that goes with it, which is an 11. So I say d of 2 equals 11. So 2 was my input into the d function, and the output was 11. On a graph, we have the same ideas, but right now, the minute number, as we can see, is in the x-axis. So our inputs are along the bottom of the graph, which are our x values, and our outputs are along the side of the graph, which are our y values on the y-axis. So over here, these numbers, 0, 1, 2, 3, 4, 5, those are our inputs, and our outputs are the numbers along the y-axis. So what I want to do is I want to find my input of 2 again, say d of 2. So I'm going to look for that. Let's go here, and I'm going to say, well, here's a 2 as an input. So I'm going to follow that up until I get to a dot. And here is that point with an input of 2. And now I'm going to see what is the output at that point and follow it over to the y-axis, and there's my 11. So that's the point 211, which means that d of 2 equals 11. Some of you might want to think about it like that, where the x value is 2 and the y value is 11 as an ordered pair. Same thing. All right, we are also going to be given just an equation. So let's see what we have here. We have d, which is the name of the function. X is the input. I have another x over here. And what I don't have is a y. Instead, it says d of x equals 5x plus 1. Those are directions on how to get that y. It's like the function machine, where it says take your number x, that's your input, multiply by 5, and then add 1. That's what that equation or that function equation is telling us to do. Take an x, multiply it by 5, and then add 1. And that's going to get us the answer. So in this case, d of 2, again, we're going to go and we're going to say d of 2 equals 5. Instead of an x, I'm going to leave a blank. And what that x is 2 again. So if you look up here and you compare d of x equals 5x plus 1, and now I have d of 2 equals 5 times 2 plus 1. You can see it looks exactly the same, except I replaced the x's with my input, which was 2. And that's going to give me 5 times 2, which is 10, plus 1 is 11. Oops, that is the highlighter. Here we go. 11. So yet again, d of 2 equals 11. We found that same answer in 3 different ways, from a table, from a graph, and now from the equation. In this next problem, I'm going to mark my inputs, which is, in this case, n. I can tell it's n because it's inside the parentheses. S is the name of my function, n is my input. So s of n equals 3 times 2 to the nth power. And I want to find s of 4. So everything I just highlighted in pink, those are my inputs. So what I'm going to do is I'm going to write this as s of blank equals 3 parentheses 2 blank. And I left out those highlighted sections. And now instead of, okay, here we go. Now instead of the n, I am going to put in a 4. So s of 4 equals 3 times 2 to the 4th power. Wherever there was an n, I now replaced it with the input, which was a 4. And now I just have to type that in my calculator or evaluate it, but it gives me a 48. So I have s of 4 equals 48. I'm going to do this very similarly. But on this next problem, I identify my inputs, f of x, inside the parentheses and x. And so every time I see an x, I'm going to highlight that in pink. And I know that my inputs are going to have to go in those spots when I redo my equation. So let's identify in this table where my inputs and outputs are. And here, my top line are going to be my inputs. And the bottom row, we're going to be looking for those outputs. So inputs are here. So what are the actual number inputs? Because there's term 1, term 2. We're just using the numbers. So 1, 2, 3, 4, and 5 are going to be my inputs. And then my outputs are going to be whatever I get from there. And that's going to go in these sections here. This is not, I'm not going to plug in 1, 2, 3, 4, 5 all at the same time. I have to do it 5 separate times. I'm evaluating one function with 5 different inputs. So first I'm going to do f of blank equals 2 times blank minus 5. Just like I did right up above, I left out the things I highlighted in pink. And now I'm going to put in my first input, which is 1. So f of 1 equals 2 times 1 minus 5. And that gets me a negative 1. So I'm going to put it right here. And then I'm going to do the next one. F of blank equals 2 times blank minus 5. And my next input is a 2. So f of 2 equals 2 times 2 minus 5. That's going to give me a, oops, that's going to give me a negative 1. This should have been a negative 3. I apologize. So there's a negative 1. Negative 3 and then negative 1. Because 2 times 1 is 2. 2 minus 5 is negative 3. 2 times 2 is 4. 4 minus 5 is negative 1. And then I'm going to move on and do f of the next one. Rewrite it, and now I'm going to put in my third input. So f of 3 equals 2 times 3 minus 5. That gives me 6 minus 5, which is a positive 1. And then I can do f, oops, she's black, f of blank equals 2 times blank minus 5. Now my input is a 4. 2 times 4 is 8. 8 minus 5 is 3. And the last one, I don't have room, but that's going to be a 5. And they're also asking me what type of sequence is f of x. So I need to look and see what is happening with my output. What's happening from here to here, from here to here, here to here, and here to here. Sometimes it's easier not to start with the negatives, but just look at the positives. So 1 to 3 and then 3 to 5 is a +2 and a +2. So I'm going to test it out. -1 to 1, yep, that's a +2. -3 to 1, -1 is also a +2. So my pattern is to add 2 each time. That means it's going to be an arithmetic sequence. Okay. Same thing for this next problem. My inputs, g of x, so there's x, and the other x is up in the, as an exponent. So I am going to, I'm going to do g of blank equals 3 times 4 to the blank. And I'm going to do that a bunch of times because I can see I'm going to have to evaluate this in 5 different inputs. So I can even write this all out. I know every time I'm going to do g of blank equals 3 times 4 to the blank. And then I have to decide what those inputs are. So my inputs, again, are going to be my top row, which means my first input is a 0. So g of 0 equals 3 times 4 to the 0. When I type that into my calculator, that gets me a +3. I'm going to do g of 1 next. That's my next input. So g of 1 equals 3 times 4 to the 1 power. That's going to give me a 12. 2 is the next input. So g of 2 equals 3 times 4 squared. So that gets me 48. And g of 3 equals 3 times 4 to the 3rd power, or 4 cubed. Again, you can use a calculator. It's 192. That's a 1 right there. And finally, g of 4 equals 3 times 4 to the 4th power is a whopping 768. What type of sequence? Well, if your number is getting really big really fast like that, that's a good indication that it's one thing and not the other. That got really big. And so I'm going to check for multiplication. 3 times 4 gives me 12. 12 times 4 gives me 48, which I could do in my head. I might have to test with my calculator, but yes, 48 times 4 is 192. And I don't know my 192 table, but yes, 192 times 4 equals 768. So what type of sequence? That would tell us it's a geometric sequence. The last example I'm going to do for you guys is a word problem. You want to buy a new video game system. You already have $45 saved and you plan on saving $15 each week for mowing lawns. The equation below models the amount of money you will have after X weeks. So they give us the equation, which means we can use it to find out how much money we have at any given time. So the question is, how much money will you have after 5 weeks? So let's do a little highlighting. X is our input. X goes here, and X is the number of weeks. So in this case, they told us 5 weeks, or to find f of 5. So that's exactly what we're going to do. We're going to do the same way we've been doing. M of blank equals 45 plus 15 blank. Every time I had that highlighted X, I put in parentheses instead. And now I'm going to put in my 5 because that's my input. So M of 5 equals 45 plus 15 times 5. And that gives me M of 5 equals 120. Okay, now that is the numerical answer, but this is a word problem. We have to answer the question that they're asking also with words. So I would say you will have $120 after 5 weeks, because that's the answer to the question that they asked. Thank you guys very much. See you soon.